Bismillahirrahmanirrahim. Assalamu alaikum. My name is Khurram Abbas. My other group members are Hamad Javed and Zaryab Rahman. Our project is IoT-based electricity theft detection. Our supervisor is respected Sir Farooq Qureshi. Introduction. A system is proposed that identifies theft in electricity network both at distribution level and at end consumer level. This system will inform the consumer and authorities about theft detection using internet. This system also tries to avoid electricity theft. Next slide is problem statement. As we know, in our country there is a huge electricity theft and line losses. Due to this, there is overcharging to the legal consumers, those who pay their electricity bills. Then there is overloading of the system due to theft in this electricity. In every year, billions of rupees are lost due to electricity theft and line losses. There is a news in dawn that over 90 billion rupees were lost during 2008 to 2013 in electricity theft and line losses. That's a huge amount. Next is our aim and objective. So our aim was to design such an internet accessible system that will detect the electricity theft and reduce line losses. But due to COVID-19, our implementation on hardware was not possible as the university was closed and we were not able to gather at one place. We purchased the hardware but were not able to work on it. So it was changed to modified aims and objective. That was to design a simulated system that will detect electricity theft and tries to avoid theft. This project has been reduced to software only and we will present its simulation. Next slide is methodology. At first, voltage and current are measured by potential transformer and current transformer. At distribution level by main control unit. Then at consumer level, we measure again voltage and current by secondary control unit. Then these measured results are wirelessly provided to main control unit that will measure whether there is any difference between these measurements. This information will also be uploaded to the server. Then if there is any difference between those measurements at legal consumer, then it inform the authorities and consumer through internet. It will disconnect the legal consumer and will transmit a high frequency power surge at the illegal consumer. So now Zara will present further.
Bismillahirrahmanirrahim. This is the flowchart of our secondary control unit. Basically, from the secondary control unit we have to calculate the values of our voltage and our current with the help of a formula of power, which is power is equals to V into A. We will get the value of power and then we will display it on the LCD. After displaying it on the LCD, that value will be transmitted to the main control unit and then to the secondary control unit. In the main control unit, we are going to request the values of secondary control units, then measure the value of power, then we have to sum all the powers and we have to check whether both the values are same which are on their circuit breaker and our SCU. If both the values are same, then of course there is no theft threat. But if yes, there is a change, then we have concluded a theft detection. Then we will do a power search. Basically we will inform the SCUs and switch off the circuit breakers to send the higher power voltage, so that if he is using some illegal things, that will be burned or he will get some loss of it. Then after waiting for 5 minutes, we can restore back to our circuit breakers and inform all the SCUs about it, and that information will go back to the main control unit. This is basically the modified block diagram of our project. As you can see from the distribution network, it goes to the main control unit. From the main control unit, it goes to the different 3 secondary control units. There are 3 circuit breakers and 3 legal consumers, of which we are going to detect the values whether they are doing any illegal consuming or not. We will send the distribution network to the circuit breaker. After calculating the values from main control unit, we will send it to the circuit breaker and then to this control unit. From the above chart, we concluded that after finding the values of them, we have to sum all the values. After calculating each value of the consumer, we will conclude that is there any difference between the reading of the main control unit and our SCUs. If there are, then it is an illegal consumer, and if it is not, then they are not. In this is our expected result of our hardware. Basically, this was the way we were going to build it, from the meter to the device and device to the gain to the meter to distribution level. This was executed work which we had done in our universities with our sir, and this is basically the picture that we were going to show you or make it worth it. This is the LED from where we will conclude the values of power, and that is our device. These are the executed work that we have to construct the potential transformer, current transformer, then we have to implement it on the SCU, then we have to simulation on the MCUs. This is basically all software work now, and then communication between the main control unit and secondary control unit, then how the information will go to the circuit breakers, and then we have to search the system. This was executed work which we had done in our universities with our sir. Are the executed work that we have to construct the potential transformer, current transformer, then we have to implement it on the SCU, then we have to simulation on the MCUs. This is basically all software work now, and then communication between the main control unit and secondary control unit, then how the information will go to the circuit breakers.
Bismillahirrahmanirrahim. My name is Hamad Javed. I am here for the result discussion and conclusion. So moving on point, earlier on we made 2 circuits, MCU and SCU circuits. MCU is a main control unit and SCU is a secondary control unit. In MCU, we can see on the left side that here we have 2 transformer, potential transformer and current transformer. Potential transformer is for making the value of voltage, and as far as current transformer is concerned, this is for the making the value in current. So basically, actually Arduino cannot take input in a current form because it is only depend on voltage. So we have to take current from the left side and then convert into voltage and then gives back into the microcontroller. Now microcontroller can simply changes the value of current into voltage by using a very simple formula, V is equal to IR. In the next slide, we have an overview of our project. Here we have a main control unit and 2 secondary control unit. This is our project. In the next slide, there is a secondary control unit. Here we have 2 secondary control units which are using our electricity, and as you can see, there is a value also appears in the screen also. In the next slide, we have a main control unit that is basically doing that thing. He actually sums the value of 2 secondary control units and then displaying us in a shape of power on LCD. Two secondary control units is just like you can take it as a consumers our legal consumer that are using electricity, and that sums up by main control unit and showing the value on LCD in the shape of. In the next slide, we have an IC that is only for internet connectivity. We have two options of ICs. One is ESP12F and the other is ESP8266. Here we are using ESP12F. We only use this for our simulation purpose. We cannot show you our outputs because for that we have to switch our project into hardware. Moving on to the next slide. This slide is all about breaker and surge circuit. On right side of the circuits you can see that here are the circuit, and the left side you can see that here is a surge. So basically when an illegal consumer comes out, then the breaker automatically turned off, and when it switch off, the surge circuit is turned on. Then the huge surge, or in other words you can say that a huge current has been given a permission to go on an illegal consumer, and in the background our main control unit MCU is continuously checking the values of current or voltage. If there is a difference come, then it automatically transfer huge voltage or current to our illegal consumer after every 5 seconds, until and unless our illegal consumer has gone. And once our illegal consumer has gone, it will come back to our normal mode. So in conclusion, we have our main control unit and two secondary control unit which measure the controls of load. Once we detect the theft detection, then MCU disconnected to all legal consumer and send a high voltage surge to a illegal consumer. Here are some attained complex engineering problems attributes that we have done. And here the reference which done us a huge help in making up in our project. Thank you so much.